right.
I just gave credit.
Okay, what's it?
Okay, just a reminder, so for those who I sent out a message for redemption, you need to read it and let me know, okay? And reply back to me that that is all clear on Zuno. I just need that, okay? Chapter 2 quiz will be at the same time as Chapter 3 quiz. It's getting hot. Shamila, can you turn off that green light there? Thank you. Okay. So, hopefully you got your notes. For 3A, B, C, and D, we're going to try and do 3E and 3F today.
And wasn't another one?
And 3E, 3F. 2G. We'll see how we go. We can catch up with tomorrow.
Oh, yeah.
Okay. We're going to start off with this.
Oi, Anto Gonzalez, we got no views, mate. We need to pump those views.
I do have views too. I think
Well,
that's
5 subscribers, we're going to get you to 100, don't worry.
I don't have any likes yet, by the way.
I like all the videos, I claim in like 1,000 tabs. That's how I use videos. I got my other account.
As long as you get it higher than Mr. Hill, then I'll be happy.
And Mr. Dunce's views on his website.
Okay, on a rough piece of paper. Shh. That's today's heading. Sketch y equals, yeah, that's the heading. Sketch y equals negative 2x squared plus 8x minus 10. I'm not going to write up the learning intention, okay? I'm going to do that at the end, okay? We'll do that at the end. You've got 2 minutes. I'll give you 2 minutes.
We need you.
So anyone got any factors in here? 10 and 2. anyone successfully break it up into two brackets?
Yes.
Okay. So, Edvika, what did you get?
I got 2x plus 10 and x minus 1.
2x plus 10 and?
X minus 1.
And x minus 1. Okay, let's see if that works. 10 times the negative 1 is the negative 10.
No, wait, is it minus 2?
Oh, you're telling me.
Okay.
Why don't you just do perfect square? Go straight into it. So can't you just go straight into perfect square?
I don't know if it's correct, but I got x plus 1 and
X plus 1?
negative 2x minus 10.
X plus 1 and negative 2x minus 10?
Yeah.
1 times negative 10 is negative 10. Let's see if this works. 1 times negative 2x. And if I bring these two, negative 10x. Does that make the middle 8x? Not quite. Good try. Incorrect. Okay. Zana, what did you get?
Isn't it negative 2 brackets x minus 2 squared plus 1?
Yes, how did you get that though?
I don't know how to explain.
Okay.
Check the factors.
Lavanya?
So what I took negative 2 as like a common factor.
Okay, negative 2 is a common factor.
So then it's x squared minus 4x plus 5.
Yes.
And then I did negative 4 over 2 squared, so minus 4x.
What technique are you using? Yeah, that's what we're doing today. Okay. Now, I actually put you on a wild goose chase because you can't actually do it with what we've actually learned. Okay.
Perfect square.
Okay. So Zainab got it. Lavanya also got it. Eric was suggesting it, which is good because you moved ahead. You know what to do. But sometimes it actually is really hard to actually get it into that thing straight away, into factors straight away. We need something a little bit more powerful that we can always count on. But the trap is with things that we can always count on, what does that usually mean? It actually means a lot more work. Okay? So, this is where our learning intelligence comes in to know when
To use the perfect
use the technique of
square.
I'll say it differently, Eric, completing the square.
That's a bit of a dodgy one.
Good. Great, you can go ahead and sit. No, I don't have time.
Okay, isn't it like...
Hedvig, but you can run it through with me, okay? Okay, now, so this thing about completing the square, hand up if you've never actually heard that term before. Those completing the square. You've all heard of it? Kai, have you heard of it? Shamila, what are you laughing at?
Nothing. Very fair.
Okay,
Yeah.
Very mature.
you're on video. Okay.
Yeah.
Okay. All right,
You're on YouTube.
you're on YouTube.
Show yourself off.
The world is watching right now.
The 15.
Okay. All right, Evika, tell me. You know this. Tell me what you did.
Yeah, first, like, you get the 2 out.
Get the 2 out. But what also do you want to get out? Also with the 2.
Yeah,
What else do we get out?
you, like, divide the 8x in half.
So we get the 2 out. Hang on. Let's get the negative 2 out first. That's the first step. So Vika, what must be in the bracket?
X squared
What goes here?
plus 4.
Plus 4x?
Minus 4.
Minus 4x. Because 2 negatives? Make it positive. And what should this be?
Plus 5.
Plus 5.
That's a nice one.
Okay, first step. You might want to write it down on the side somewhere, Aldi. Aldi, what are we talking about? Number 1, get any factors. Because the first goal that you want to get is an x squared. The first step is get an x squared. Write that somewhere. Yes, Divansh.
So from there,
Okay, so from there. Yes, Divansh.
you could do x squared
X squared
minus 4x
minus 4x.
plus 2 to the power of 2.
Hang on. What 2? What kind of 2?
I just said positive 2.
No.
You're stupid.
Okay, I'm just gonna.
Oh,
No,
yeah,
it's
yeah,
basically
yeah, I see.
This is gonna look confusing
Now
if you haven't
minus
had
the same
practice.
Wouldn't you minus it, sir?
Yes.
Yeah.
I'll
And then we'll make
edit
it positive.
Yeah.
So basically my thing was the
And then
same
minus
thing.
10.
that out. Okay.
Or minus 5.
And
Plus 5, but you're getting this.
okay.
Stupid boy.
So completing the square. If you'd like to know why completing the square works, you can YouTube Eddie Wu. He's got a
We're going to
great.
YouTube you, sir.
Okay. He's got a great video on making it clear. So if you're one of those people who needs to understand why, go to Eddie Wu. Now, over here, all you have to do in the bracket, you write the first 2 terms. So write the first 2 terms. You can even write that. Get an x squared. Write first 2 terms. Once you've done that, you're going to halve the term in the middle. You're going to halve the term in the middle. Halve the middle term.
Stressing. Stressing.
So we've halved it. We've done an addition and a subtraction of it to cancel it out.
We did this last week.
We add.
Partially. You and your laptop the whole last year.
And we subtract it and then write the rest. Now, this here, I'm missing a bracket up here.
Yes. Yes.
Say it one more time. That middle term gets halved. We do an addition of it and a subtraction of it. If it's a minus 4, you must have minuses in here. If it's a plus up here, you must have pluses in here. Our next question is, are these 2 equations still the same?
Yes.
Yeah.
Why, Zana?
Because you added and subtracted, so they cancel.
Because we added and subtracted it to make it go away back to this. Okay, so let's keep moving forward.
How disrespectful. We're filming on YouTube. You gotta be on YouTube.
And yes. Is this?
So you have to use your editing skills.
Okay. Okay.
Oh, we're not going to focus.
Now, if we have too many brackets going over the place, what can we do? Advika?
Factorize.
No. Presenting it correctly to keep track of different sets of brackets. What's a good thing that we can do? The answer is not yes. Is that
Make the brackets look different. Like
Make
a
the
square
bra-
bracket.
make the brackets look different?
It was no need for that.
Okay.
Oh, you just want that.
Now, shh. What's negative 4 on 2?
2 is 2.
Negative 2.
Plus
What bracket should I have here?
square.
Okay. Negative 4 on 2, negative 4 on 2. They're actually negative 2s.
Wait, so
Okay?
how do you make the bracket look different?
Just
Just
keep
make
track
it
of where we're
easier.
at.
Just
Easier
to
to
show the
look at.
finishing product.
Wait, it
Don't ask too
actually
much
becomes
questions.
Okay,
x
once we get to this step here, all you need to do, I might show an extra step by the way.
We did
Should I put it in?
Should you? Negative 2 times x minus 2 squared plus
I'm
1
gonna-
equation.
Negative 2 squared is? 2 negatives make 8?
4.
And 2 squared, 4. Minus, what does this do?
4.
4 plus 5. Okay, remember, this plus here, 2 negatives are normal 4, 2 squared is a 4.
What's it? F.
Minus, and negative 2 squared is a 4. That minus is this minus. Okay, so now the trick is this. What you do, you get your x, you bring this one, I'll put in colour,
Then you distribute it.
once it's all set out, it'll be really clear. That x squared is just an x in the bracket. This here, this negative 2, will just simply come down here, and you just write it as a negative 2. Squared.
Oh, then you here.
And what's minus 4 plus 5?
1.
It's a 1. Now,
You got a graph?
I'm going to take a break here. Celsia. Good. Great. Yes.
Yeah, I got
Okay, that's a very good question, Celsia, and a very good comment. I'm gonna get back to that. Hashi. Sorry? Plus 1. Minus 4 plus 1. Okay?
So can you sketch that?
Yeah, we'll get that in a second. Okay, now, you might be wondering, you're probably not wondering, but you might be wondering, how can I get to this when that doesn't even look like this, and this doesn't even look like that, okay? How can these two be equal? But it all comes down to what we have in the green. Okay, this is green, which is also this green here. What I'm trying to say is anything in a green box is equal. And let's prove it. So in a different coloured pen on the right hand side, what you might want to do is this. X minus 2 squared. X minus 2 squared is the same as
X minus 2,
x minus 2, x minus 2. I hope the camera's picking it up. Okay, Panya, x times x, x squared. What else do we multiply? Negative 2x. What else do we do? Which
Two
are
and two
these two?
X.
Sorry,
Negative 2x.
another negative 2x. And what's the last
Positive
thing?
4.
Plus 4. If I clean that up, x squared,
They cancel.
negative 2x, take away 2x.
Negative
4x.
There's a negative 4x plus 4. Where do you see that?
Right
On the
underneath.
second last
The
one.
second box.
But you can make it go further.
Okay? So, this means it's true. Well, I'm saying this green box is equal to this green box, which is equal to this green box. If I go back expanding this out up to here as a check, if I expand it back out, it actually ends up being this green box in here. It's the same thing. But the technique is from the beginning. All you need to do, once you've written out your first two terms and halved it and squared it and then did a takeaway of it, because why are we doing it add and take away? Because why are we doing that?
What was that, sir?
Why do we do an add and take away?
To make it neutral.
To make it neutral,
Yeah.
So it can go back to its original state.
so it can go back to its original. Okay? But the shortcut in completing the square, and we'll get back to Celsius' comment, if you want to go from here to here, x, take it out, the value in the bracket is a -2, that comes out as a -2, and then we square it. And that's the proof that they both equal this middle green box in here. Okay. And then from here, I can times it back in. -2 times the first thing. And what's -2 times +1?
-2.
-2. So, what's the advantage? This equation up here is what we call polynomial form. It's called polynomial form.
That's on 3F.
Polynomial form, where you have x to the power of 2 and it's all without brackets. Polynomial form is all without brackets. What's so good about completing the square? What is the advantage that you can see in the last line of completing the square? What's the main advantage? Devansh.
You get to know the it comes in the form of y equals a times x minus h plus k.
What's that called?
Turning point.
Turning point. Turning point.
Turning point
This man's got more brains as
Just by looking at it in this form here, what's the turning point?
2 -2.
2 -2. Remember, in the bracket, we think opposite. If it's a -2, it's a +2. This stays the same. Okay. Now, once we're there, we can start doing some work of sketching the graph. Okay? What's one thing that we need to find out, Rosella? What's one thing that we need to find out when we're sketching a graph? Just one of those things that we went from last week. There's 3 things. The y
turning.
and that's when x equals 0.
Now
But we know from the polynomial form, if I put a 0 in there, what am I going to end up?
-10.
-10. Okay? So we know that that's the y-intercept. What's the next thing if we have a y-intercept, what's logical? The next thing that we can
X-intercept.
Thank you.
Okay, x-intercept y equals 0. So with a 0 here, okay, let's do some backtracking. Maha, help me out.
In what?
Backtracking, let's get x by itself.
You put 2 on the other side.
Is 2? Jack, what do I do next?
So,
This bracket is being multiplied by a -2. Opposite
so
of that is
divided by -2.
divided by -2. 2 divided by -2, Eric.
We'll do just 1. Would you expand the brackets?
No, no need for that. Actually.
Okay,
You're gonna square it.
hang on. Before
Square
we
it
expand
is
the
not
brackets, there's a quick way we can go around this.
Double it, make it into
Square root. Can I square something for it to be a negative? No. Conclusion?
No real solutions.
No solutions. Okay, we could do that, Eric, but when we do that, you might get go on a journey. Okay. Now, my next question:
left one, no solution.
if we did the same thing up here,
Circles like this. Yes.
You got 2 x's.
if we did the same thing up here,
Yeah, if you're gonna get minus 10.
okay. If I see how I solved the 0 for the equation down here, if I did it for the one up here, will I get anywhere?
No.
Let's give it a go. Just give me a second. I'm trying to illustrate something here.
So you need better way.
You can tell us what's going on.
And then you switch it.
Drone. Just stop talking. Catching cases. Just keep
Can I solve this as a 0 to find the x-intercept?
Yeah.
Okay. How could I do it?
Take the 10 left.
get rid of the
Take the 10 left, and then what?
Ah,
Divide
factorize
by
it from
8.
there.
Okay, if I start factorizing from here, like that,
Yeah.
okay,
Nah.
what's wrong with that?
Nah.
Why can't I solve this? Not quite. Can I solve this? Why can I solve this one? Why? What law are we using? The null factor law. Can I use the null factor law for this?
No.
Why?
It's got 10.
Because there's a number there. See, if you use completing the square to get it into turning point form, you can actually get somewhere.
Well, you got nowhere technically.
Well, yeah, so yes and no. We've got no solutions. We found that out. But here, if you get stuck with that, you can't actually prove anything. You're just stuck. Here you're stuck, but you've got a proof that you can't have a square that turns into a negative. Okay. Completing the square is a lot of work, but the advantage is, what's the first advantage? Again,
You get to see it. You get to see it in the turning point form.
you find the turning point clearly, and you can prove also clearly if there are solutions or not.
So with that type of equation at the start, like when you get a question like that, so it's better to use the completing square,
Yeah.
not the other method.
Yes, but there'll be down the track. There's a new method to actually make things easier, and you probably touched on that last year. Okay, which I'm not going to mention. Okay. All right. So,
What are you doing?
do I have enough information to graph this?
Yes.
Yes.
Okay. So we go graphing. Now, what's my turning point again? 2, -2. So it's really important because it's a 2, -2. I'm focusing on the bottom, so you don't have to put it in the middle. Okay. So we know there's a 1 and 2. At x-intercept, there's nothing there. -2. My y-intercept is
Negative 10.
negative 10. Let's just fix this up. Negative 2, negative 4, negative 6, negative 8, negative 10.
You have to do it on the right as well.
This is 2, negative 2. Did I miss something?
Negative 10.
Ah, thank you.
The 10's not.
Oh.
Okay. And then here, connect the dots. Easiest part. Done. Okay. Now, you need to know completing the square because you'll get tested on that. Okay. So Sia, how did you do yours the quick way?
I can't see that. Can you just look at my notebook?
I have a quick look. Yeah, you just had less working out. That's still right. Okay, so Celsius was completing the square. Now I'm going to show you a quicker way to find out where the turning point is. Has anyone seen this before? Has anyone seen that?
Yes.
Quadratic formula.
Yeah, it's from the quadratic formula. So this little machine makes things really quick. So if you don't want to do completing the square and you're not asked to do completing the square, you can do this. Okay, looking over here, we have an A, we have a B, and we have a C. What's my A hashi in here? Negative 2. What's my B, Hanan? What's my B?
8.
8. And my C?
Negative 10.
Negative 10. If I put it in this equation, my negative B, negative 8, 2 times an A, what's my A?
Negative 2.
Negative 2. That's negative 8 over negative 4. What's that equal to?
Positive 2.
2. Oh, let's go back up here. Right there. That's the 2.
Nice substitute.
And then we substitute x equals 2 into our equation. Okay, so these become 2's. Sorry, it's a bit small. 2 squared times 2. Negative 8. 2 times 8, 16 minus 10. What number do I get?
Negative 2.
Negative 2.
And then we get
And that goes here. Well,
So much easier that way.
okay.
So,
Yeah.
instead of doing all of that, if you just need to find the turning point, you can use that.
Yeah.
But when
Exactly.
it asks for completing square, then you do.
Yes.
Well,
So,
Correct.
why would the stack ask for components?
Yeah, well,
Is it part of the key knowledge?
it is. Very much so.
So,
It is part of the key knowledge.
So what if we didn't know that this didn't have an x-intercept? How would we figure it out? This can't be continuous.
Yeah, that's correct.
So would you have to do completing
Yeah,
square?
you would. You would.
But what if you knew like it's going upside down and that's the turning point and you already know that there's not going to be an x-intercept? Can you just write that? Or do
Yeah,
you
you
have to show
could.
words in
I guess you could write that in words. If you,
Or do you have to show
So that means
that's a really good question. For me, I'd accept that you do know the nature of the turning point and that it's going down from 2 negative 2. Okay? Alright, so we have a negative b on 2a that makes things out quickly. Okay, you might want to use that when you have a choice. Okay? No, wipe this off.
you can do what you like. You're the teacher.
Let's go over here.
You're the head of the YouTube.
So, I'm gonna buy
Yeah. That's a bit later on. We'll go there later. Okay. Next one. Okay. Have a go at this right now. Sketch y equals x squared minus 5x. Okay. Just by looking at it, where is our y-intercept, Celsius?
0.
Where's our y-intercept? Just by looking at it. There's something there, but it's not there.
0. The origin.
It's 0. Okay. Yes, they'll give you that. It's in polynomial form, but there's actually 0 there. So we know straight away y-intercept is equal to 0. Okay. Alright, so we've done one intercept. Let's do x-intercepts, okay? How do I start that off? Show me what. X-intercepts for this, what can I do? What needs to happen to have an x-intercept?
Y equals 0.
Y equals 0.
Jerome, stop the time.
Just the kids like
So 0 equals x squared minus 5x. What can I do now?
Divide by, go divided by 5 on 0.
negative 5.
Negative 5.
Negative 5?
Like, get rid of that negative 5x.
You sure about that?
Like that?
Not really.
Well, you trying
I
to
just went brained it.
It's okay. We can use that formula. Okay. How?
So you already have an A and a B, you don't need a C, but you already know that there's no y-intercept. So it's going to lie on the x-axis.
It's going to lie on the x-axis,
So
yes.
it's going to be just the x-intercept.
Yes.
So when we sub it into that,
What do I substitute?
A and B.
Okay. So let's do this. Talk about that, Lavanya?
Yeah.
Okay. Now,
A is negative 7.
what, Jerome, is by B in here?
B is negative 5. 2 times 1.
2 times 1. Okay.
Choose 5.
Which is 5 on 2.
Yeah, negative.
2.
2.5.
Oh, that's something.
And Lavanya, what do we do with that 2.5?
We sub it into the x.
Wait, there's a 1 negative. How do you get positive 20?
Okay, when you substitute it in, it's better to use fractions.
Let's see how it's negative. Negatives over there, so you get cancel stuff out.
Do I should have 5 squared? Over? 4. Okay, Aldi, what does this turn into? 5 times 5? Over?
2.
2. 25 on 4. What do we need to get going before we do more work? One to 4, 1 to
3
2.
cross multiply.
Cross multiply?
Like.
Or what can we do to the second bit?
We can times it by 2.
Times it by 2.
Negative 15.
Over?
Over 4.
So make it the same difference.
So it's 25 over 4.
It's minus 25 on 4.
Minus
25 on 4. How many 4s fit into 25?
no.
6.
6.25.
Almost. Close.
0.25.
What's the remainder?
0.25.
1 over?
Do it.
4. Okay.
Ah, yeah.
So, what did that achieve? turning point. 5 on 2, -6 and 1/4. Sorry, I'm being a bit naughty. One's a mixed number, the other one's a improper. Doesn't matter. Okay.
Put that in the set. That now.
No way.
It won't matter. Why would you put that in the set?
Sir,
Yeah.
do you think your answer in mixed
Make it hot.
form or like
Do you
improper?
want to go brain dead?
It doesn't matter.
Yeah, no, if you want to
Okay.
sketch it, yeah.
Okay. Now,
Is this 3 E?
sorry,
Is this 3 E?
this is 3, yeah. Okay. Let's graph. Turning point is 2.5, -6. So once again, I'm moving up. I'm moving the x, the y equals 0 line up. Yes.
Isn't it basically -6?
Huh?
That one.
Sorry.
Isn't it -6?
Yeah. -6 1/4. 0.25.
I'm surprised you can cut it.
Let's jump.
I'll keep it down. I'll try to keep it down for you.
Okay, so we've got a y-intercept at 0, 0. And we've got another thing. What's the other thing?
Turning point.
Turning point. So, thanks, Jerome. 2.5, -6.25. So 2.5 here, and -6.25. So,
Bit like right.
I'll put in decimals here, just so it's a bit clearer. We've got that. The next question is, as Lavagna has used it to find the turning point, remember that the turning point is halfway between the two factors.
So it'll be the same on the other side.
Okay? So if I've got 2.5 that way,
You'd have that.
how much do I go the other way?
2.5.
2.5. So if it's already at 2.5 and I put another 2.5, what number do I end up at? At 5.
Oh yeah. Very nice.
Okay. So let's go again. We already know one intercept, 0, 0, and it's 2.5 this way. But because it's symmetrical, the other place that it hits the line is also another 2.5.
So could you find it manually?
Yes, we can.
Can you try?
Why do you have to just call it?
Okay.
Why do you want to put it out?
So the thing about, what do we call these things?
Parabola.
Parabolas. The thing about these is that if you find a halfway mark,
Axis of symmetry.
yeah, there's an axis of symmetry at 2.5 right down here. That's what I was looking for. This is an axis of symmetry equation. That's the line. Right in the middle. So if I already know that that's 2.5 and this is 0, I can also, through symmetry, I can go 2.5 that way to find my next intercept, visually. But Devant would like some mathematics behind that.
Of course.
So the mathematics behind that is, let's put x-intercepts y equals 0. What is common between x squared and -5x? What can I pull out?
X.
What must go in the bracket?
X.
null factor law, yeah?
Yeah.
X equals?
0.
X minus 5 equals?
0.
0. Yeah. And then, jump the gun. X equals 5 here. And X equals 0 there. 0 and 5. 0 and 5. Okay. Alright? Okay. So if you're a visual person, you might want to do it that way. But if I'm asking for the maths, go that way.
Chemistry.
Okay.
We need everything.
Let's see if you almost there. Yeah, what you would do, you can write through axis of symmetry. I know that the next intercept, you can write it down, will be 2.5 to the right. Okay, another way. There's actually another way.
Of what?
Finding out the answer.
Is it delta?
I'm gonna do it.
Lambda max.
7 times.
You know.
48 mathematics. Delta is actually.
Let's I'll do it using the other example.
Close enough.
All right, next question.
TF minus TI.
This is flux. That's mechanical. That's area.
All right.
Touching kid.
Next example. Sketch y equals x squared minus 4.
Easy.
Easy peasy lemon squeezy.
Okay. What form is this, Rosella?
We can literally just sketch that.
This actually, this is 3. This is 3. Oh no, we're into 3. Okay. What form is this? Tanya, did you hear you?
Why are you doing that?
Polynomial. Okay. What's good about polynomial, Stephanie? What's good about polynomial, Celsia? What's good about polynomial, Hashi? No, one specific thing that you can read off.
Yes.
The y-intercept. Okay.
-4.
Shh. Jerome, what's the y-intercept just by reading this?
-4.
-4.
With 0.
I can simply read it off. No maths involved. Okay? Just reading it off. What can I work out next in? X-intercepts. Y equals? 0. Can someone solve this right now, please?
Yes,
How do I
I
do
can.
that?
X is 2.
X equals 2.
2.
Really?
Yes, it is.
No, it's 2. It's 2.
It's trying to trick you.
Okay, let's do it 2 ways. Opposite of -4 is?
4.
Square root x.
Opposite of a square is it?
Square root.
What must I do with the square root?
Plus
Minus. X equals plus minus what?
2.
2. Let's do it the other way. How can I factorize this? X plus 2, x minus 2. Notice that Lavanya has said that this is a difference of perfect squares. One of them's a minus, the other one's a plus. X minus 2 can equal to 0, x plus 2 can equal to 0.
X is equal to 2. X is equal to
You can, whichever way you want to do it, it's your choice. Okay, now, if we were
sketch it.
Think about. We've got time.
Hey, Jerome.
Has it been nice? Has it been nice?
How's it been in Nons?
How's it been in Wesley?
No,
How's it been what?
I purposely did that. Okay. Now, F1. What dots can I put on here?
You can put the y.
Which is?
0,
1, 2, 3, 4. Don't you? 0, -4. What's another dot, Eric?
You can put the x equals 2 on the other side, -2.
Okay. Looking at the way everything's spread, is it what word am I looking for? Symmetrical. If we want to be if
symmetry
parabolas
is 0.
are symmetrical, therefore, where's the axis of symmetry?
0.
Which means where's the turning point?
0. 1, 4.
Where's the turning point?
0, -4.
0, -4.
Answer, my dude.
So in this case here, we have the turning point, which is the same as the y-intercept.
Like drawing
Oh, that's a very good question. You can Google that. Alright, let's use this. Let's use this for a moment. Don't complain.
You're gonna get the answer.
What's my B?
-4.
Ooh, wrong. 0, sir.
It's a 0.
Does -4 have an x?
What's my A in here?
One.
What's my C?
0.
That's
Okay, B is a 0. 2 times what's my A? It's a 1. What's this going to turn into anyway?
0.
Axis of symmetry is 0. That's why. Okay.
This guy's too good.
Okay. So you can actually do it visually and meet in the middle.
Photo time? You would say photo time?
You would.
Have you already had your photos?
Nah.
Did you just have a room swap from SU?
No.
Okay, all good.
Thank you.
We're not going for photos.
You have period 3.
These girls are gonna go crazy because
Alright.
it's gonna get destroyed.
So-
by fourth period.
You have options, axes of symmetries. You can just you can work out your solutions to work out where it's halfway. Okay. Now, there's actually one more example here, but we actually did it last 2 weeks ago, so I'm not going to go through that. It's in the notes. Read that tonight. If you have any questions, let me know. Now, just to recap, why advantage of completing the square is to look at the turning point clearly. And it shows you with the maths working out mathematically if there are solutions or not. Alright, I'll see you guys tomorrow.
First period tomorrow. You got us to do 3A at home?
I'm going to talk to Mr. Dances first.
Don't know how much.
Yes, you may.
Their laptop to be reconnected, please.
I'm going to talk to Mr. Dances about the sax, but can you pick up one of
the office? Olivia Bakakoulis, Charlotte Blair, Morgan Cheney, Daniel Sadiq, Nora Al Aboudi, Valentina Miladoni, and Cooper Hutchinson. Thank you.
Working's like the wider than the Jerome just like next level one.
Have you seen Edward Song?
Yeah.
What? You can't even see his song?
Oh yeah.
So I don't have you on Zoom. Still hasn't updated. I talked to Mr. Malcolm, but he said if it doesn't change, I have to wait for Mr. Malcolm.
Okay. Can you guys see him? If he's free.